center solution for the USA Teen Selection Test 2021, problem 1. At first, let's have a look on the problem statement. We are asked to find all integers s greater than or equal to 4, such that we can find a, b, c, d from the positive integers, such that a plus b plus c plus d is equal to s, and the sum, which is equal to s, should divide abc plus abd plus acd plus bcd. At first, when we see this problem, we see that we have 5 variables, namely s, a, b, c, and d, and we only have 2 conditions, namely that the sum is equal to s and s divides this sum here. Therefore, our first try is to get some better conditions out of the given condition in the problem. And since we know that the sum of a, b, c, and d is equal to s, and that s divides a polynomial in a, b, c, and d, it's maybe a good idea to consider all this stuff modulo s. So we can write down that 0 is congruent to a, b, c plus a, b, d plus a, c, d plus b, c, d, because s divides the right hand side here. Now we want to work with this expression here, and since we have a lot of variables, it's maybe a good idea to get rid of one of these. Therefore, we can use the condition that a plus b plus c plus d is equal to s to get rid of the variable d. Therefore, we can at first factor out b from these 3 terms. So this is equal to a, b, c plus d times ab plus ac plus bc. Now, since we know that a plus b plus c plus d is equal to s, we can say that d is congruent to minus a minus b minus c modulo s. So maybe I should notice here that we work in modulo s the whole time, and therefore we can write that this is congruent to a, b, c minus a plus b plus c times this term here, ab plus ac plus bc. Now, our first instinct is maybe to multiply all this stuff out here, but if we have a closer look, we can see that this abc term is also here because we multiply c with a times b, and since we have a minus sign in front of these 2 factors, this abc cancels out. So let us at first only multiply this c term out. Thus we get that this is equal to a, b, c minus a plus b times ab plus ac plus bc, and now c times the second factor, which is minus cab minus c squared a minus c squared b. And as I already said, the abc cancels out. Moreover, we see that here we have an a plus b term, and we also have a times c squared and b times c squared here, and therefore we can factor out this a and b here and get that this is equal to, I write down the minus sign in front of all of this, a plus b times ab plus ac plus bc, and now we have also the plus c squared in front of this. Now we see that ab plus ac plus bc plus c squared is b plus c times a plus c, and therefore this is negative a plus b times b plus c times c plus a. Now we found a factorization, and this is really nice because in most of the problems where we have some divisibility arguments, it is very important to find some factorizations. Indeed, in this problem, this factorization is key to solve the problem. Because if we have a look on our expression here that a plus b plus c plus d is equal to s, we directly see that all these terms here are less than s because all of a, b, c and d are positive integers. So we get that a plus b is less than s, b plus c is less than s, and c plus a is less than s. Now we immediately see that s cannot be a prime number because otherwise s would divide one of these factors here and all these factors are less than s. So we get that in the first case where s is prime, we get no solution. Okay, so the second case is now that s is equal to m times n, where m and n are both greater than or equal to 2. So now, in order to get this product here to be congruent 0 modulo s, we want to have these two factors, m and n, as factors here. Therefore, maybe our idea is to set a plus b equals m and a plus c equals n. The easiest way to achieve this is if a is equal to 1, b is equal to m minus 1, and c is equal to n minus 1. Okay, and now the last thing we have to prove is if d is also a positive integer. Therefore, we can use this equation here that m times n is equal to s is equal to a plus b plus c plus d. This is equal to 1 plus m minus 1 plus n minus 1 plus d, and this is equal to m plus n minus 1 plus d. From this, we can now bring m plus n minus 1 to the left hand side and get that d is equal to m times n minus m minus n plus 1. And here we can factor this as m minus 1 times n minus 1. But we know that both m and n are greater than or equal to 2, and thus this is greater than 0. And therefore a equals 1, b equals m minus 1, c equals n minus 1, and d equals m minus 1 times n minus 1 is indeed a solution. And therefore, for every s, which is a non-prime number, we get a solution to our problem. And therefore, we are done.